This is the future of high-speed transportation. It's 3.5 times faster than Japan's Shinkansen bullet trains, even faster than a Boeing 747. It's a hyperloop, magnetic pods levitating inside a tube at more than 1,000 kilometers per hour.
Look at this experiment a little closer. There are three main components to our train. The battery, which is the source of electrical current and electrons that power the train. The coiled copper wire, which is the conductor that creates the closed circuit that the electrons travel through. And the magnets, which generate two of the magnetic fields which help to move our train. The magnets which are placed on the battery have both a north and south pole, and they need to be aligned in a specific way for our train to move. The magnets attached to our battery need to have their north poles pointing in opposite directions. This will be very important once our train enters the coiled wire. When we place our train into the coil of copper wire, the magnets on either side of the battery touch the wire and create a complete circuit. When the circuit is complete, electrons flow out one side of the battery through the coil of wire and into the other side of the battery. When electrons travel through a conductive wire, they generate a magnetic field, and each loop the electrons travel through combine magnetic fields together to create a larger magnetic field the length of our train. The poles of the magnetic field generated by the coiled wire are positioned so that the magnet on one side of the battery is repelled or pushed, like when you bring two of the same magnetic poles near each other, and the other side of the train is pulled through the wire, like when two different magnetic poles are brought near each other. The push and the pull on our magnets cause a forward motion in our train, causing it to travel through the coiled wire. The magnetic field generated in our energized coiled wire follows along with the train as it moves. If the magnets are not aligned correctly, both sides of the train will be pushed or pulled at the same time, causing equal force on both sides and no movement in the train. There is one significant difference between the train in this experiment and the motor we made in a previous episode. The train uses the magnetic field of a current to push magnets, and the motor uses the magnetic field of a magnet to push electrons, or electrical current, moving a wire.
Passive maglev uses permanent magnets in a specific configuration to create a constant magnetic current that levitates the pod, similar to the magnets you might have played with as a kid. Active maglev uses a combination of permanent magnets and electromagnets, the latter which can manipulate the electric current and the strength of that. Similar to existing maglev trains, the hyperloop concept removes a key element that holds a lot of trains and planes back: air resistance. Vacuum pumps come in handy. Both companies are installing pumps along the tube. For Hyperloop TT, these pumps, located every 10 kilometers, theoretically would suck out 99.9% of the air between the capsule and the tube. Removing air drag could be the difference of some 800 kilometers per hour.